Welcome to 2 a.m. Philosophers. Today we are going to talk about templates and generics, and this is a topic that is very useful. Some of my friends got questions about it on their interview, and a lot of them say that they encounter templates in their code bases in at work and it's generally something good to know. And in huge code bases, it's often used, and it can make the larger code bases look a lot more organized and help the developers to keep track of everything in their mind and also write cleaner code. So let's get it started.
Look at the code tonight. In the glow of the screen light, lines of logic take flight. We could get this right. Templates and generics flow. In silence, we both know. Java and C++ show different paths where we go. 2 a.m. philosophers, thinking deep under the stars. 2 a.m. philosophers, in the world of ones and zeros far.
All right, so my reference for today are these two websites. Um, Here we can see, let me first explain why we need uh, templates, and then I go over these examples. So basically, um, it probably happens to everyone who's written C++ or Java code or any type language that they sometimes need to write the same function for two different um, parameter types. So let's say, in this case, let's say we want to find a max, and we we might our input might be a string, might be an int, might be a float, might be anything. And it's just annoying if we were to write the same function over and over again. Um, so what templates enable us is to basically write um, one type, like one function, and have the type to be this generic type t, and the compiler at compile times basically looks at t, and based on the sort of way that is the function is called, it generates uh, code with the correct types. And it's not just for functions. We can have class templates. So for instance, in this case, we have a class called array, and the um, we get this template t type name t, and then we can use that in this case as for the type of our pointer. So let's maybe we can quickly go over one example here. I copied or actually wrote this code. One of my friends got this question on their interview to write basically dot product or something similar, and the interviewer asked what if we were to use so they were using int, and they asked what if we were to also use double or float as the input, and the answer was that okay, we should use templates. And basically what this function is doing is taking a vector of type u, and that's a template that we define, and this is taking a reference, so not a copy of the input, but the input itself. So here we set it to const because we're just returning a dot product. But if we wanted to, if this wasn't the const, we could have directly changed these values. So we take A and B, we loop over size of A and multiply multiply A position I and B position I and add them up and return um, very straightforward code. And as you can see, we can basically call the same function with different types. Yeah, we have the very similar concept in Java as well. They're called generics, and probably the most famous example would be lists. So the list class, when you instantiate it, we use this syntax. Um, and here we are, um, you know, we are declaring the type, in this case, integer. So I wrote an example here. This function takes basically an array of any type, or sorry, and um, the idea is that we want to convert this array um, of any type to at least um, of of that type, and so it could be, you know, um, an int, a string, and the same function can be used. So here I have this example where we have a string, um, but we could uh, quickly write another example where we have, um, you know, integers as values. So let's say here list integer, list2. Yeah, Replit right now also has this AI generated um, code or code suggestion, which is amazing. So let's see what would be the result if we had um, integers and variable t has incompatible bound. Also interesting. Okay, so because the lower bound is an object, we should use um, this type, integer with capital I. But yeah, uh, pretty useful. Um, I've seen this T used in Java pretty often, but I think templates are much more common in C++, and I hope now you can you know what they are and you can use that when you write code.
Type safety.